Welcome to the MLOps Live webinar series, where we dive into what really takes data scientists into production and how you can create real business impact with AI. I'm Edith. I'm the head of community and open source marketing at Iguazio, an AI startup that was acquired by McKinsey back in 2023. And I am so glad to have all of you here with us today. We have a really exciting session lined up. Our topic today is going to be accelerating and scaling AI deployments across hybrid environments. We'll explore how Safaricom, a leading AI mature mobile operator in Africa, tackled major bottlenecks and operational challenges to speed up their time to value. You'll hear their stories, the obstacles they face, their vision for the future, and we've even got a live demo of a custom Gen AI code generator that runs right inside your notebook. I'm not going to give it all away, so stay with us. But before we begin, I am thrilled to introduce today's speakers. We have Hillary, the head of AI at Safaricom, Anthony, the lead machine learning engineer at Safaricom, and Selesh, the principal architect at Iguazio. It's going to be a really great session. So without further ado, I'll hand it over to Selesh to get us started.
Thank you, Edith. Hello, everyone. This is Selesh Desai, Principal Architect with Iguazio. For those of you who don't know, I'll quickly give an introduction of Iguazio. Iguazio is part of McKinsey and McKinsey's AI arm Quantum Black. And what it is an AI platform and a tech stack which helps develop production scale AI pipelines and AI applications across traditional AI, Gen AI, and agentic now. What you see on this page is a construct of AI Factory, where we have the full cycle of AI from pre-processing, which is data management. By the way, it can start with a marketplace, which we have, ML Run Marketplace, where we have predefined functions and codes and notebooks which can be used to develop pipelines, training, inference, and serving across the life cycle. So number one, you see pre-processing data management, where we can create pipelines with ML Run. And what ML Run is the baseline of Iguazio. It's an open source machine learning orchestration platform, which you can check on open internet. It's all open source. And number two, you see development, can develop training pipelines, models. It could be even pre-processing data engineering pipelines, and even agents or RAG for kind of Gen AI workloads. And you can deploy it. It scales with any CI/CD application. You can do GitOps. The underlying infrastructure, it's compatible with both on-prem and cloud hyperscalers. So it can be plugged into infrastructure as code, and any CI/CD tool or a pipeline which is in continuous, which is in currently in use in any of the organizations. This also fits well into model serving or live ops, which is number four. We can continuously monitor the models pipelines for both functional and technical metrics, like model drift, or bias, or etc., even hallucinations in cases of LLMs, etc. What we see is literally, I think, a lot of technical elements. So there's elements of feature vectors, feature stores, which standardize pre-processing and feature creation, and models can be wrapped into ML Run functions, and all of that within the Iguazio platform. There's a construct of projects, which gives a structured approach of AI development, deployment, and we are building AI for production readiness from scratch. On that note, I'll pass it on to Hillary. Over to you, Hillary.
Thank you, Salesh. Thanks for that introduction on ML Run and Iguazio. I think just to set the context, I'll talk to what Safaricom is. I'm sure most of us might not know what Safaricom is as a company. Safaricom is a telecom tech company in Kenya. Kenya is a country in Africa, and Kenya currently has a population of around 58 million Kenyans, and Safaricom currently is around 24, 25 years old, and it offers different products to its customers. And currently, Safaricom has more than 50 million active customers across the country, and it also does offer. It has, with all the product offerings, it has created more than 1 million jobs directly and indirectly. It's also listed on the Nairobi Stock Exchange, so meaning it's publicly traded. The biggest innovation from Safaricom that everyone knows is called M-Pesa. M-Pesa, M dash Pesa. Pesa is a Swahili word for money, so it's basically mobile money, where our customers can transact via their mobile phones. And this does not necessarily have to be a smartphone. It can be an entry level, a 2G phone, or any kind of phone that is registered on the network. The transactions can be sending money to each other, receiving money, pulling money from your bank, sending money to your bank, paying merchants, buying fuel, and you can imagine the use cases are endless. Other use cases across investment and the likes. What is, just to show you the quantum of how M-Pesa is, 59% of Kenya's GDP is actually processed through M-Pesa. So M-Pesa is a huge product from Safaricom. One of the, of course, now that you know Safaricom and the quantum of data and products that it has, you can imagine building any AI system requires a lot of plumbing, a lot of proper design. Initially, what we were doing as a company, as an AI team, was we had so many components that were completely decoupled from each other. And this created a lot of friction, especially when moving from one stage to the other. So moving from a data scientist notebook or from a data scientist code, we had to give it to a MLOps engineer to refactor the code and then put it in another system. The system could be, some systems or legacy systems, and trying to make sure the plumbing cuts across properly used to take more than 3 weeks, sometimes even months. And what we were looking for was something that would also remove the complexities and kind of let the data scientists do the data science work and concentrate on the data science craft, the MLOps person to concentrate on the MLOps craft, and all the data engineers to concentrate on the plumbing and the pipelining of the data engineering craft. So we went ahead and had this partnership with Iguazio, and what we saw from the very first experiments or POCs we did across multiple use cases or solutions in Safaricom, some simple, some a bit more complex, required more plumbing. We saw more than 5x time to production, and this was something that we were really looking for, to cut time to value, because we are a very fast-paced organization. We were also looking for a framework that would give us standardization and kind of automated AI deployments. And by that, I mean abstracting all the complex work that a data scientist doesn't need to think about. So things like your containers and pods, and spinning up pods, or creating domain names for APIs, or creating APIs, and all these things come out of the box with Iguazio, which is great for what actually we wanted to achieve. The infrastructure we have is also GenAI ready, and Iguazio also gives that, because now you can build anything on top of Iguazio that is AI related. You can even go ahead and build a web app. You can build any agentic system on top of Iguazio. And the major one that we were actually looking for, that also we saw a lot of impact and improvement from our perspective, was just traditionally, or before Iguazio, pre-Iguazio, what we were doing was our cloud infrastructure was completely separated from our on-premise infrastructure, meaning anything you build on-premise was hosted on-premise, and everything was being done on-premise and completely decoupled from cloud. But with Iguazio, at least we are seeing a hybrid approach that we're really gunning for, because now today, if something fails on-premise, we can very quickly switch to having it run on cloud. And what this happened very quickly in the initial stages of setting up Iguazio. So we created this thing we called a migration party. And the reason why we had the migration party was internally we were doing some migrations from different data centers on our infrastructure because of different internal reasons. So the main thing was, can we move some of the core use cases to cloud? And the cloud we are currently using is AWS, but this applies to any cloud. Can we move some of these use cases to cloud, and how fast can we do it? We had a migration party that lasted 1 day, and the most impactful thing out of this was the team actually managed to migrate 16 use cases, 16 AI use cases, cutting across different verticals, and some cutting across the whole company. The use cases around, some around Gen AI, others around discriminatory traditional machine learning. 16 use cases were migrated, and in a span of 2 to 3 days, all the use cases were already running on AWS. And this, we could not have done this with our traditional infrastructure and our traditional setup. So Iguazio actually helps us move faster. It increases productivity when developing and when deploying, and it makes things way easier because it enables the developers to concentrate on their vertical, on their skill verticals. So data scientists will start becoming very good at data science and forget all the abstractions that have been done for them around the plumbing of having Kubernetes run, having pods running, and all these things. And then the MLOps guys will concentrate on the other things. I will hand it over to Salesh and Anthony to take us through the before architecture. Back to you, Salesh.
Yeah, so this is again going back in time where we saw a use case, propensity use case, and a real-time app serving models were getting served to an mobile app, mini apps on top of M-Pesa. That was specifically the use case. Steps 1 to 11, where there were kind of configuration files, Java-based, some scheduling, and notebooks were passed on to MLOps engineers. And we saw some scope of improvement around how it could be organized or productionized in a more consistent way. And we have Anthony here. I think he can talk about what exactly were the problems, and subsequently how we kind of simplified and made it 4 to 5, maybe even more times faster. Over to you, Anthony.
Yeah. Yeah, thank you, Salesh, for the introduction. But I think I'll begin by maybe laying the ground for a high level of statistics, and where Iguazio comes in now to the specific use case that we want to talk about here. But ideally, the focus point is what Iguazio did for us, and maybe what it can do for you if you're working in an AI environment where you need to scale out or hyperscale out in terms of your delivery. Yeah. So think about this. There's a recent study that have recently came out, where it is 90%, over 90% of AI use cases, they never see the light of the day, or they're never commercialized. That tells you have only 10% chance to succeed if you're an ML engineer. You are doing whatever use cases that you are doing. And when you drill down, another study that was conducted by Google, there's a paper they wrote called The Hidden Technical Debt in Machine Learning Systems. That basically tells you there's a cost that you need to pay even before you start delivering that amazing business problem that you want to use AI for. And that's where the Iguazio comes in. You can choose to spend your time as an ML engineer, data scientist, doing the groundwork of software engineering, the DevOps. As you can see on the screen here, we have at the bottom there Jenkins, we have MLflow, we have different tools. We have Hadoop, we have Postgres. All these tools needs to be joined together and orchestrated so that for you to deliver that one single use case. Now coming down home into our context at Safaricom, we used to have different teams that are supporting this workflow in a very fragmented manner, where, as Hilary had mentioned, my colleague, it will take days or even months to deliver a single use case because we didn't have a predefined standard. And if you have worked on this field, you know how difficult it is. It is very simple on paper to say we are going to deploy this use case and scale it out to 50 plus million customers in our Kenyan market. But just imagine the effort it takes for this flow, single flow you are seeing on the screen here, to be implemented and be able to be scaled. And I don't mean just scaled, securely scaled. Because the moment you hit on production, that button for production, and the customer starts enjoying the benefit of that predictive use case for that particular business value, the customer expects something to be secure, always on, and make sure they are guaranteed of the service that you have promised them, the promise that you have with your customers. So the flow here shows the old states of how the things were. Yeah, and what we did on Iguazio just comes in and making sure you have paid that technical data I talked about, and you spend your time solving the customer problem, not doing the software engineering, not doing the plumbing of the CI/CD. Jenkins here at the bottom here is an orchestrator that we are using now to try to glue everything together and make it work. So maybe go into briefly into the details, like maybe 30 seconds. At the far end, step number 1, we used to have our big data platform, which we normally use to store massive streams of the data that we normally collect for the different metrics from the customer behavior angle. Then we pre-stage that into PostgreSDB, all open source. Then again, we need a scheduler to come in and be able, let's say we are running this daily or monthly for different outcomes. We're using an open source tool called Airflow. You can see I'm on tool number 3. Those are 2 different systems running on different servers that need to be maintained independently and making sure they are working in sync. Then we go again to writing out the metrics of how that ran, that was scheduled, back to Postgres maybe. Then we can go to doing the actual modeling. And that's where you see the step number 8, where we are doing the notebook. That's where a lot of time was being spent. Over 80% of the manual labor was being spent there, where we needed a handshake between the data scientist and the MLOps engineers. A data scientist is working and cooking in the lab, trying to develop and define the business KPIs, define different problems. But now, whenever we are done in building that amazing solution, we need a handover now to ML engineer, step number 9. ML engineer comes in and their work is to optimize and scale out that solution and making sure it hits or sees the light of the day into production. And that's where now we do things like containerization using another tool called Docker. Again, we go back to Airflow again, and until we say we have deployed. All these tools need to work in sync in different server systems. And that's where the challenge comes in. And hence, what I said, the hidden technical debt in ML models. And that's where now the state comes into how do we solve this problem of where we don't want to focus on the plumbing and solving the problems that are not kind of helping the customer, but they are very important in terms of making sure the solution runs. And that's where Iguazio, as an end-to-end orchestration engine, comes in and pays this debt for us very well. I don't know if I can proceed to the next slide. Yeah, this is now the revamped state. Yeah, we have collapsed this into very few steps into the Iguazio, and as we go to the demo, we'll be able to see these. I don't know whether Salesh want to comment on this before I dig deeper into now the current state for Iguazio. Salesh, you can come on.
Yeah, thanks, Anthony. So again, what I think we started with, why don't we standardize and I think clearly reduce the number of steps, and what enabled us to do this was actually Iguazio. Now, pre-processing, of course, there's a Spark operator, which wasn't used extensively, but again, we started with feature engineering, feature vectors, came into picture, which standardized how features were developed. And even though Iguazio has its own feature store, but we use the kind of the inbuilt or the in-house feature store at Safaricom. And then existing models were wrapped into ML run functions, and same with inference pipelines. And then there was some downstream monitoring kind of jobs and the way we track the metrics. So literally, we reduced the number of steps from 11 to 7 and a half. Again, given there were some CI/CD, etc. aspects, which again, the existing pipelines were used. We didn't restructure the actual models. We restructured how they were being put into production from pre-processing to serving. I'll hand it over to Anthony. I think he has been working with the team day in and day out to how they've approached this in real life.
So maybe now to go to the specifics of the platform, and there's an open source tool called MLRun that now is orchestrator, like the orchestrator or the brain within the Iguazio ecosystem. Actually, you can just go to your browser right now and find it in GitHub. It is open source called MLRun. MLRun is the orchestrator that helps you to treat various components in this workflow as code, DevOps as code, deployment as code. You know, you're not going and then unifying all the ecosystem and all these tools into a single entry point when you want to deploy, when you want to build an API, etc. So instead of having these fragmented systems that we were showing in the previous slide, now you have one unified or one workbench where different components at the right place at the right time. I don't know. I know at Tech we don't like a lot of PPTs. So when you go to the demo, you go to see the platform and what we are talking about here and how it glues everything together in a very nice way. As I was saying, I like viewing it as a build and deploy your own code. That's the best way I simplify that technical flow from an Iguazio angle. Build and deploy your own things. I don't know, it is unheard of, especially in the data science world. How can I build my own model and have the capability to deploy without having to necessarily hand over that handshake to another team, another system? In my Jupyter notebook, and Hilary will talk about this, how can I build and deploy on myself? So here I'll briefly, the reason I'm not focusing so much on the details of this one, because it is on the screen and we can quickly go through it right now. We collapsed all that into now this is MLRun. What you can see as Iguazio platform here, it is basically MLRun, which is an inbuilt tool within the whole ecosystem that comes with the feature engineering capability. That's what we are calling the feature vectors. So you're building, because it is connected to the remote data sources, you're building your features or reading your features from your central features catalog using the same tool that you shall use to deploy your use cases. So you're not jumping from one tool to the other, and that makes your build process to have a linear kind of a flow, and you don't jump from one build environment to the other. Then when you're done with all those, we can, in the same notebook, if you like, or you can chunk it into multiple notebooks. And by notebooks here, I mean Jupyter notebooks. I believe most of us, we are conversant with that technical tool that is loved by the data scientists and ML engineers. You can train your model. Then when you're done with it, you come in step number 5 and orchestrate the model inferencing and deployment using MLRun. So what is MLRun? And I think the biggest misconception that I've seen, especially in terms of onboarding the tool, and I'm sure we are all checking it maybe online, is thinking MLRun is coming to replace what you normally do as a data scientist. No. MLRun comes and says, okay, you are done building this particular use case. For example, in our case here, Giga and Mini apps for various predictive use cases. When you're done with it, using the normal scikit-learn, using the normal XGBoost, all the packages that you normally use in your data science flow, all MLOps flow, when you're done with it, now I want to make this production ready. Remember I said, build and deploy your own use case. That is where MLRun comes and kicks in, because under the hood, Iguazio as an AI platform, it has been built on top of what we call Kubernetes, or K8, which is a container orchestrator platform that comes and automates all these DevOps, CI/CD processes that we were doing manually. Previously, we had to write the Jenkins pipelines manually. We had to write the Kubernetes deployment, the Docker files, YAML files manually. But now MLRun has simplified that, but saying we are going to give you DevOps as code. We are going to give you monitoring as code. You as a data scientist, you just call a set of APIs. By APIs here, I mean some modular functions that have been pre-built for you. So whenever you want to package and deploy something, it becomes very easy. You don't even have to leave your Jupyter notebook. And all those things like auto-scaling, they come for free. I don't want to use the term like a free lunch thing. There's nothing like that. You still need to do some simple gluing, but that's ideally where we are heading. Like maximum automation of AI flow, ML flow, and making sure the time to value is accelerated. Because at the end of the day, for all the AI flow, if you go back to that research that has been done recently, the faster that you can iterate and experiment and making sure you're collecting the results from the experiment that you're doing, the faster you can be able to scale out the AI use cases. I don't know, I'll hand over briefly to Salesh to give an intro to the next slide, if you don't mind.
Yeah, thanks, Hilary. So here what we see is another use case, more of an NPS kind of a character use case, where there was some standardization, at least in pre-processing or upstream steps. By the way, this use case had pretty kind of large, at least the raw data sets and various types of data sets. But we figured out, again, there were some kind of duplicate or some steps which could have been optimized, which we'll see. I think, of course, Anthony would talk about what were the real kind of problems, but we again figured out all of this can have a similar structure to the previous use case, and a lot of complexity around pipelines could reduce, because at the end of the day, we're solving for a business use case, and that's what we did. Over to you, Anthony.
Yeah, again, we see another very complex use case that we managed to kind of scale it out and be able to implement it very fast into the accelerated MLRun engine. Imagine you have a use case that requires 10 plus different data sources, very complex pipeline. I don't know whether Kevin, my colleague, is on the chat. Somehow he can comment there about the use case. But different components that need to work together to make sure that use case is delivered. And it took, on a manual deployment process, what you're seeing here, the odd state, this use case took almost an year to even complete, depending on given the nature of its complexity. But when you think about it from a very high level, all these different components that we talked about, which are very similar into how we looked at from the previous use case, you can clearly see there's a kind of a pattern or a system of operations in terms of how an AI or a machine learning model hits production. You follow at a given defined steps that are almost the same, but now the depth and the complexity can kind of be different, but it's the same dance that you're dancing. And that's why now it comes in, can we simplify and accelerate this process using the ML run? So I'll quickly jump to now the current state. If we can push, then yeah, this one, perfect. So using the same Iguazio AI platform, this use case, we chunked it into kind of modular high-level steps. Number one is automation of the data and feature engineering, all the same using MLRun. I'm emphasizing on that. So we are not kind of using MLRun to kind of open connection to the databases. I want to make that very clear. MLRun does not dictate, or Iguazio does not dictate how you write your data connectors, what libraries you are using, how all those things are upon you. But if you have predefined them and making sure your scripts are working fine, now MLRun, as you can see it here, it kicks in and tells you, okay, give me your scripts and all these nice code that you have written, and help me package them for you in terms of how to scale them and run them into kind of a modular system that is scalable, because I'm running under the hood. I'm coordinating on your behalf with the Kubernetes. I'm coordinating on your behalf with Grafana. I'm coordinating on your behalf with the monitoring tools that will be able to ensure your model is scaled out and always on, and metrics are being monitored. And that's what basically we have here, MLRun as an orchestrator of your different ingestion pipelines, the feature engineering pipelines, the feature vectors, and we'll see all this flow when you go to the demo, the training components. So instead of having Airflow here and you cannot see it here, MLRun comes in and kicks in and tells you, because under the hood, we are using something we call the Kubeflow, which is basically DAG-like orchestrator that you can be able to glue different steps. The step number 1, number 2, number 3, number 4, all the way to the serving and the inferencing. They are glued together using the Kubeflow to make sure now you have the capability of scheduling. So instead of you leaving your Jupyter notebook and going to another system like Airflow, where you have to write another DAG file or a script manually, MLRun still on your notebook, you just import a few sets of packages under the hood from MLRun, and you're able to schedule from there. So instead of having to go and write your login into another server, then you break away from the flow, that state flow that you're in, you're able to do it on your Jupyter notebook. Again, that's what I said. If there's one thing I want you to take away from these theories that we are showing here, it is that I want the capability, or the MLRun gives you the capability to build and deploy your own models, your own use cases, and not just deploy them, scale them out in a secure way, because it comes with all these tools of making sure the environment is secure, it is auto-scaling all the way from the data center. Yeah, and I think we can quickly jump to the other slide.
Yes. Thank you so much, Anthony, Hillary, and Celeste, that you guys really set the stage here and gave great context. And I think your point, Anthony, of building, deploying, scaling, and taking your AI projects really to production and to see the real life business impact is phenomenal. So before we continue, we have a lot more to get through. Before we're going to go through the demo soon, I just want to launch the first poll. And we really want to hear from you. We try to shape these sessions to really, be based on topics that are interesting to you. So I'm going to go ahead right now and launch the first poll on, are you building AI agents? So you should see the poll launched on your side of the screen. And if you don't mind taking a minute and answering that, we would really appreciate it. So are you building AI agents? No, you're just learning. No, but you're planning on to. Yes, I'm experimenting with AI agents in the lab. And yes, I have AI agents in production. And yes, I have multi-agentic systems live. So wherever you are on the journey, please do let us know. All right, handing it back over to you, Hillary.
Thanks, Edith. So I think we've heard from what Anthony and Salesh have already talked about. So I'll go through this very quickly. But from an AI perspective, what you really want to go for, especially for a company like Safaricom that is serving 50 million plus customers, and some of the use cases are real time, and you need to make sure the experience is seamless. You want a system that is simple to maintain, a system that is simple to use, and a system that is always up. So this architecture that you see, the initial architectures you're seeing around 9, 10, sometimes even more than that number of steps, this has collapsed all this into very simple components that need to be managed, and these components are out of the box. So for example, with model monitoring, you have excuse me, you have all the drift monitoring metrics that you want defined. You define them, you monitor them, you're able to set triggers for retraining. Other things include things like domain names. A data scientist, when a data scientist is experimenting or building, they don't have to write code to generate an API endpoint, as an example. They just use a job and say this is a serving job, and it gives him an API endpoint with a very clear domain name that they can use for testing or share with the stakeholders for testing. Other things like Anthony mentioned around auto-scaling, which are very key, especially when you're working in a large team and when you're working with many AI assets. That is very key because you want to make sure things auto-scale and performance is always maintained at a specific threshold and a specific standard. For Safaricom, data quality is also key because you're dealing with many customers and you're dealing with very sensitive customers as well. Having the feature engineering and feature store components that we've built internally integrate to Iguazio directly is a big plus. So what you see here, feature engineering and the feature vectors, you can use the out-of-the-box capability on Iguazio, but Safaricom we've built our own internally and we just plug and play. And the beauty with Iguazio is also it also integrates with other workflows like Kedro. I'm sure you saw in one of the old architectures there was a framework called Kedro, which helps you in building DAGs. You can build the DAGs and pipelines in Kedro and actually integrate it directly to Iguazio and have that run very seamlessly. The other push towards this, especially from a strategic point of view, are cost efficiencies. You're running a Kubernetes cluster. If you're to think about it from a very simplistic point of view, that is all you're running. The things that run on top of it are now the Iguazio runs on top of the Kubernetes cluster. As long as you have that cluster, that's it. You just install Kubernetes on top of it, and you're good to go. Your management of your infrastructural management becomes very easy to do, becomes very cost effective. So from a strategic point of view, as Safaricom, just talk through like 3 pillars of some of that are really driving us towards these kinds of setups and these kinds of systems. So we are gunning to become completely AI native, and the reason for that is we've done our experiments over the years. We've done multiple POCs. We have many AI assets, as I mentioned earlier. We are venturing into other markets and having other subsidiaries, and the efficiencies and productivity efficiencies that come with having systems that help you scale quickly, having systems that make you move into production quickly. Remember, like we mentioned, migrating the 16 use cases into production in less than 3 days. Initially, it would have taken months. That is a big plus in terms of value. So being AI native, well, that is where we are currently are. We also did a POC on MLRun in one of our sister companies, which is in Ethiopia. And other subsidiaries, and we're seeing a lot of success coming out of that. The future vision for this is to have a seamless hybrid deployment across cloud and on-premise. We already have the cloud setup done, the on-premise setup done. It's already seamless, but scaling that out to our subsidiaries to make sure they also enjoy the benefits that we are seeing. On the migration side, like I think I've already talked about it. What we are seeing in the future is just having standards in place to help us around inference. We are learning a lot around, especially in setting up LLM inferences and I mean inferencing around LLMs. And how to scale that and how to scale it properly to serve many customers, both internally and externally. And there are many tricks around it. So the future is to have multiple multi-agentic systems running on top of Iguazio. Today we'll show you one of them. Hopefully everything will be quick and easy to understand. Then the other strategic AI initiatives are around greenfield use cases. So just to be ready for any greenfield use cases for the future, to future-proof anything that is coming to us, that we can actually build and show value and increase efficiency and increase value for our shareholders is something that will be a plus, both for our current state and for the future vision. And we see Iguazio as a very good partner that will help us future-proof what we want to do and whatever side or whatever direction AI takes. I think with that I'll hand it back to to Anthony to take us through the first bit of the demo. So the demo will be around a custom GenAI code generator, but Anthony will take us through the first bit, which is the API gateway. Over to you, Anthony.
Yeah, thank you, Hilary, for that. I think, as you're noticing, I'm the tech guy, yeah? Hilary is the money person, eh? So I'll quickly share my screen. I'll do a quick share. I wanted to be, I'll jump quickly to, if you can see my screen. This is now the platform, the Iguazio platform that we have deployed in our environment. From a very high level, still focusing on what the platform offers you in terms of now how it can accelerate a specific demo that we shall be showing, the GenAI, but overall wise, it is not only GenAI, it supports almost any use case that you can think of, from the real-time APIs to dashboards, etc. Yeah, but overall, this is what we mean, eh? Think of the MLOps life cycle. We have built, then now we want to deploy. That's where now Anthony Kick comes in, and you want to scale this out. Eh? And then what does the platform offer you? Under a single roof, at the right place, at the right time into your MLOps life cycle, you find a project management, you find a feature store, you find you can explore your data, etc. This is now an overview of the major like components that we have. But for today, we won't go into the details of the specific of the platform. I think you can find it under the iguazio.com. But this is just a brief overview into the comprehensive nature of the platform. Overall, what I want to focus on, because the demo will be primarily based on what we normally call the Jupyter service. Just imagine, even as an MLOps engineer, a data scientist, you have onboarded a new data scientist, and you need to give them a new working environment. Besides the capability of enabling the auto-scaling things that we are talking about on a project level, the platform also offers you the capability to quickly provision a new service, and the services can be of different types. For here, I'm selecting the Jupyter notebook, but you can see you can create different services for different users. You can create a Spark service. And by a service here, we mean, this is a terminology from the Kubernetes. We want to deploy a container, a standalone container, isolated for that particular new user you have onboarded. So you quickly onboard the data scientist and you create a new Jupyter service for them. And automatically, they'll get a Jupyter notebook that has been deployed on a unique URL that they can be able to access from their browser, that is isolated and not shared. If you understand how the Kubernetes work, it deploys a pod that is isolated and ephemeral to that particular user until it is restarted or shut down. So this is where now we land now to the actual demo. We have assumed I have clicked the service, I've created the next step, blah, blah, blah. We are not going to do that right now. We're just communicating that capability where a user gets their own Jupyter notebook and they're able to work there on their project in an isolated manner. And they can choose to share. There's a capability to make sure you can collaborate with the different users. So for the GenAI here, as a platform also, because we have deployed the system with the capability to have the GPUs access, we have different GPUs in the backend that are running in our data centers. So we are able to orchestrate, and Hilary will show a specific demo of a use case we have built for GenAI, but I'll focus here in showing you how easy it is to deploy an LLM endpoint. And for this particular one, within a few given steps, just imagine the headache that you have to go through installing the NVIDIA drivers in your server. If you have ever gone through that CUDA installation, the headache, sometimes you can even spend 3 days trying to install the CUDA if you've ever done it. Yeah, it is not a nice experience. But here, all those suits have been abstracted and done for you, because we want you to focus as a data scientist or an MLOps engineer. We want you to focus on what really matters and cutting down as much technical debt as possible. That's why I said you have this model for this particular use case. Let's assume it was a normal use case, but for now, we never train the LLMs. We just maybe downloading from Hugging Face. They are quite expensive to train, etc. So you have your model ready. and you want now to deploy it and scale it as an endpoint. That's why I said build and deploy. We are on the deploy section here because you're not training an LLM. So you just import the ML run, then you have your model to deploy, and the only thing that you require under the Iguazio ecosystem or ML run ecosystem is just create an umbrella or a project using the ML run. You will see there is nowhere we shall be defining how we do the model training or the model build. After that, you just provision a few things, what we call the reverse proxy, just to enable. You can see the difference here. We have the model, you jump straight into the deployment and handling things like the APIs. Then you come and configure the application runtime by telling it where to find the model, where to find the image. Remember, everything is containerized. So the best practice are enforced by default. So whether you like it or not, you have to deploy your models in a containerized nature, meaning by default, you are following the best standards of making sure you don't have some isolated batch scripts that are running in a server somewhere in a corner, such that when you leave the company, no one will ever have the capability to take over and continue with them. So by default, by you working under the environment of Iguazio platform, you find that you are forced in codes to make sure you are following the best standards, because the best standards now will give you the robust and the capability that we are looking for. So at this point, we create just a few steps. We just set there's something we call the functions in the ML run ecosystem. Then you define the port where the API is going to be running. If you want to adjust your limits, like the resources, the memory, that control, all from your notebook. Remember, if you were to do this manually, this will be a very complex YAML file from a Kubernetes angle. But right here, as I said previously, we do the CI/CD as code. That's why I say build and deploy your own use cases. That's the power that we are giving you directly from your Jupyter. And now this is how we manage to get the 5x acceleration in terms of how we define a business use case and getting it into production. Because you are not leaving your Jupyter notebook, you're not switching from one device to the other. All of it, you are doing it from your Jupyter notebooks. Again, which is very important, if you want to target a given node, let's say we have different node groups. That's also a terminology from the Kubernetes angle. We have deployed our cluster in such a way we have different nodes or different server for different workloads. We have the normal day-to-day nodes. We have the heavy nodes for training that handle the heavy training that contains the GPUs, because you don't need to be attaching a GPU into every server. It's a very expensive resource, and you need to maximize its usage as much as possible. We also have inferencing nodes. So again, from your notebook, without having to call an infra guy or a DevOps engineer, you're able to target where I want my code or my model or my API to run. And that's the power, without calling an MLOps engineer into the whole MLOps flow. Then finally, you come and set what command do I want to run for that particular. For this case, we are using VLLM. If you know, VLLM is an open source tool that use something we call paged attention in terms of making sure it is able to scale your inferencing API into production grade workload, the nature of the workload that we handle at Safaricom, given our customer base of over 50+ million customers. Then finally, you create your API gateway. And when you create your API gateway, and this is where the awesome part comes in, you can guess what we shall get. Of course, I'll show, I had run this previously, so I'll show the output of this section. Create your API gateway. As you can see here, what happens is very interesting. If you follow this log here, it is going to build your pod in the backend. Remember, we are running in the Kubernetes environment. When it does the build, then when it is finally done, then it tells you at the end here, successfully deployed the function. What it has done, it has orchestrated and built a pod for you, packaged it without you having to write a single DevOps pipeline, Jenkins pipeline, the way we saw in the traditional method that you are following. Then when it is done, it is successfully creates a unique subdomain that you're just able to click here without leaving your notebook and be able to immediately start testing it. And how does that API look like? This subdomain has been kind of crafted for you automatically. You don't have to, there's nowhere we configured the port, the domain that we want to use. You know the headache, if you've ever done MLOps deployment, of how you have to go of wondering, how do I configure the DNS? You call the network guys, how do I scale out this one to make sure it is HTTPS? Again, you call the cyber security. All that has been handled and in the backend by the platform, by it being a unified system that making sure you're finding the right components at the right place at the right time. So how does the API look like? When you click on it, you directly go to the first API that now has been provisioned with a custom unique domain. If this is not magic, I don't know what magic is. For me, when I started using the platform, because I used to do all these manually, and it would take weeks and months and days in terms of gluing all these things together. And this is how you deploy an API. And with that, I'll hand over to my colleague, Hilary, to talk about money and business value.
It's interesting how MLOps engineers always believe they're more technical than data scientists, but that's a joke for another day. So I not only deal with money issues, I also deal with building AI systems. I want to show you something that we've built that enables our data scientists to be more productive. So I don't know if my screen is visible. Just give me a thumbs up if my screen is visible.
We can see it.
Thank you. So we've built this very simple library that we call Kazuri, and what this does is basically it helps the data scientists be more productive in the notebook. So remember the whole ethos of simplicity from Iguazio to what Safaricom is also gunning for in terms of technology, abstracting all the complexity in the backend, but giving people the power to be very productive. So we call it Kazuri. So what all a data scientist does is, after opening a notebook like Anthony showed you, is you come and import the library just like that. The library is already imported. Then all you do is you call it like this. So you call it and give it instructions. So this is just basic instructions that I want to use to show you what it does. And what it does is it will call the endpoint Anthony created, and then generate the code that needs to be generated, and then it will spit that code in the next cell, and then the data scientist can either edit that piece of code, or they can go ahead and use the code exactly as it has been spat out. I don't know why it's taking more time than it should. Let's give it one second. Anyway, as it does that, so it will spit out the function that will add the two numbers. I think because I'm running off the VPN, that's why it's taking a bit of time, but we'll see that. So what I did here just for the demo is I created this prompt, and the whole idea is to remember we talked about M-Pesa earlier. And when you deal with anything to do with money, there are always people who want to do reversals. So this prompt is basically saying, can you automatically create code that can be used to create a web app, and the web app will be able to give people will be able to chat with the web app, and the web app will be able to give people answers around M-Pesa reversals. So this is a prompt I give it. When I run this, it spits out, it says check code below. It spits out this code below here with everything in place. All I do is just add this write file to, so I save it as a Streamlit, as a Python script. And after saving it as a Python script, I just package it. So I zip it, and after zipping it, that's it. My code is ready to be deployed. Then when I go to the deployment phase, there's just boilerplate code that I use that I think Anthony had talked to a bit earlier, where I give my app a name. So I give it a ridiculous name so that you can see how it looks like when it spins up. It's using my folder. I create a project, and Anthony talked about creating projects, which are kind of the entry into everything that I'm doing. I create a reverse. I use a reverse proxy image, and the reason for using a reverse proxy image is because we are sitting behind security layers and proxies. and that's basically it. The other pieces are just boilerplate code, basically using this Safaricom registry, picking the Streamlit code where I had saved it earlier. Remember, we zipped it and saved it. We pick it from there, and then I just tell it the command I'll be running is Streamlit. This is how the thing will be run. The port to specify for the run, and that's it. And if I need to add any build commands on top of it, I just come and specify them here. So install Streamlit, TQDM, and open Excel, and that's it. And that's basically it. And then I say create the gateway. I mean deploy and create the gateway. This is what it does. It goes, spins up pods, does the installation, does everything in the backend, does the building and everything else, and it gives me this URL. But this URL, you remember the ridiculous app name I gave it? It kind of attaches that to the domain name so that it's easier for me to know. So if it's a key project and I've given it a descriptive name, that descriptive name comes under this, and when I open it, this is how it looks like. And that's it. Like in a matter of seconds, you've built a Gen AI agent that will be able to answer questions. So let's ask it a question like, how do I do an M-Pesa reversal? I hope the proxies will not mess us up on this one again. Yeah, there you go. It gives you an answer, tells you what to do, tells you everything else. And this has been built and it auto scales. You can monitor the metrics, you can do everything else, and that quickly and that easily. I don't know, Anthony, do you have anything to add on this deployment piece? Anthony?
Yeah, I wanted to briefly now show that auto-scaling element and how you can easily manage it from the Iguazio platform. If we head back and show I'm sharing my screen, if you can see it, confirm. Hilary, you can see it?
Yeah.
Yeah, I can
Now
see it.
from the API that we have deployed, you can see here that API, that unique link that we saw from the Jupyter. Now from back, you can go, the user will normally go back to the dashboard and you're able to manage things like security, the tokens. If you want something to be authenticated using a token, you can set it, yeah, on the dashboard. The auto-scaling capability, or the way, you're doing things as code or low code as possible, and data scientists can do it. Things like we normally require to call a DevOps engineer, like increase my memory, scale my pods to the number of replicas. You have the capability to control all that all the way now from the UI and the platform. So besides you deploying and be able to see your unique URL, etc., you can even test that link directly from here. Instead of logging in, having to install Postman, we normally use Postman for HTTPS request and testing. You just go back to the same platform under the single roof, and you're able to send different kind of request, put, get request in the same link that has been auto pre-filled for you. You can also have different triggers. Let's say you want to add a Kafka trigger. There are so many different triggers that you can add on the system. If you want your API to be event driven, let's say new documents are coming in from the customer, either from the customer call center, and they are coming through our Kafka platforms. We have done this complex workflow that we might not be able to go through today. I'm just highlighting the capabilities that are there, and it would be awesome to catch up maybe after this webinar and see how different users are onboarding in terms of accelerating the MLOps journey with the Iguazio platform and ML Run, which is basically open source. So thank you so much. That's it from me. Back to studio.
Thank you so much, Anthony. That was great. And I think that demo really gave a lot of people something to think about. So thank you so much for presenting, Anthony and Hillary and Salesh. Let's dive in to the second poll. So I'm going to go ahead right now and launch the second poll. I know there's a lot of challenges when dealing with AI agents, But we would love to hear what your biggest challenge is with an AI agent. I know there are many. Try to choose the one that resonates most with you. Is it AI hallucinations, working in a production environment, cost, data privacy, multi-agent communication? There are many, and I think that you touched upon many different challenges that you guys, as Safaricom, through your journey, have encountered. So we'd love to hear from you, our participants. What biggest challenge are you facing with AI? I'll have the live Q&A. Please don't go anywhere yet. Anthony and Hillary and Salesh, if you guys want to turn on your cameras, let's hear from our participants. So there are a couple questions that I saw, Salesh and Hillary, that you guys answered throughout the session. Why don't you each maybe kind of, Salesh, why don't you start with one? I saw there was one on LLM Judge. Why don't you choose one that you think would be most relevant for the group?
Yeah, one of the questions so I think within LLM inferencing is LLM is a good standard. I think, of course it is. I think we actually have a demo. I just posted a link. Maybe if you want to evaluate your AI outputs, I don't know, of course, RLHF is one of the ways. RLAIF is also one of the ways if you want to go reinforcement learning way. And if you want to use something else, which is a bit of a tool, of course you can do it. I mean, Iguazio itself is not a LLM provider, but if you want to evaluate some LLM or for kind of hallucination toxicity, you can do it with some kind of a third-party external tool.
Great, thank you so much, Salesh. Hillary, why don't you expand a little bit more on one of the questions that you were elaborating on in the Q&A?
I think one of the question came from Tiana. I hope I got the pronunciation right. She asked quote unquote, hello, if I grab it well, do you mean the system could be all gathered into a Jupyter notebook? Please specify. So I'm sure through the session and through the demo you've seen that, yes, that kind of that is actually the correct answer. So you can think of this as, normally you would have different pieces of Python scripts or whichever language you use, and then you run them separately on Kubernetes to manage the pods and do all these things and try to figure out how everything merges into each other. But what this does is you have your Kubernetes cluster running, and then on top of that you have a Jupyter service running, and all the data scientist does, like I've shown, is through the Jupyter notebook, because they are very familiar and very quick to use these Jupyter notebooks. They code on the Jupyter notebook, and everything else that is happening in the backend is completely abstracted. So the MLOps people or the MLOps engineer like Anthony would go and look at are the pods running, but still the data scientists can also see this metrics if they want to, and they can also shut down pods if they want to, giving them a very good balance of simplicity and complexity. So if you want to build things very simple, you can go ahead and build things very simply and quickly through the notebook. If you want to go very complex, you can still go ahead and do it very complex. It does not mean that you can only develop on a notebook. You can also develop off your IDEs, so you can build the scripts separately and then run them and push them to run on your Kubernetes cluster via Iguazio. Thanks.
Thank you so much, Hillary. Anthony, was there something you wanted to add on or discuss from the Q&As?
No, I think all the questions have been answered by Salesh and Hillary. So yeah.
Yeah, there was someone that messaged me privately. I just want to hear from you, Anthony and Hillary. Some of our participants come from smaller organizations, and I'm sure that you can, relate to that from your years of experience. But how do you feel smaller organizations with fewer resources, or just kind of starting off with scaling? From your opinion and your experience, where should they start, and what resources should they replicate from everything you've shown?
I think I can give a brief on that, maybe before Hillary jumps in. I normally run an open source version of MLRun in my house. This is more me going geek mode. I have a mini server, a very commodity hardware that you can buy off shelf. It is able to run the whole open source solution If it runs in my simple machine in the house, then you can imagine you can quickly jump into it into terms of experimenting with very cheap commodity hardware from any organization that you wish. And that's where I would advise anyone to get started on, because we have done it even for bigger deployments using the open source. Then from that on, you can decide what's a fit for you. But that's where I would start.
Yeah, thanks, Anthony. I think from my perspective, from a data science perspective, you would want to start by not necessarily looking at the technology, but looking at the problem that you want to solve. Kind of structure it in a way that you really know what problem you want to solve, what value you're going to get out of the problem, and that will guide you to know whether you want to go with buying your own servers or renting servers or going through a cloud approach or having a hybrid approach. But then from there, things become very simple, because if you have hired one data scientist, as you have seen, the moment the infrastructure is present, the moment the software has been set up, you don't need to hire a larger team. That one data scientist can build and deploy, and things will move very, very fast, and you'll start seeing value very, very quickly.
Wrap up, I would like to invite you to explore our website at iguazio.com. You'll find past webinar sessions along with a wealth of additional resources like blogs, case studies, best practices, and we'd love to hear your feedback as well on content you would like to see. So without further ado, I just want to say thank you. This was a great session. I really enjoyed, and a really big thank you to Hillary and Anthony and Celeste for your presentations, the demos, your hands-on experience, and your wise words. And of course, a heartfelt thank you to all of you for taking time and energy and participation out of your day. We really are happy that you joined and look forward to seeing you at our next session. Have a great day, everyone.